All right, hey AP Chemistry, I wanted to show you how you're going to use this template to plot your data. I set it up purposefully that it automatically does the calculations for you, so it's a bit easier. So when you open this, yours is not going to be shared. Yours is going to say view only. What you're going to do is, as soon as you open the template, you're going to go to File, make a copy, and then you'll save it to wherever you need it to go. So I'll save this as Tadaldi example. So Tadaldi example, and I have a bunch of different folders. You just might have one quick drive that has all of your documents. I would suggest making folders, and I'm going to do that, and then it automatically opens it in another tab. And once you've made a copy, since it's your copy, you can edit it now. And so now I'm going to pretend to plug in some data. And so let's say I have a time 0 and I recorded volume every 10 seconds, and I am making this up. So 10, 20, 30, 40, 50, 60. I did it for a minute. At 0 time, I should have no volume of H2 that is produced. At 10 seconds, maybe I saw 2.2 milliliters. And look, it automatically does the calculation for you. I have it set up nicely that it will automatically calculate each cell for you. Let's say at 20 seconds, I saw 2.6. Then 30 seconds, I saw 3.8. 40 seconds, I saw 5.7. 50 seconds, I saw 7.2. And then 60 seconds, I saw 9.8. Okay, I completely made up these numbers. All right, now the way that I have this set up is that it's plotting your time. I'm going to highlight that. It's plotting your time versus your moles of H2 that are produced. And that's really all I want you to be able to know how to do for right now, knowing how to plot the data. So it plotted time versus moles of H2 produced. On the x-axis, which we can have that labeled easily, right? Horizontal axis, I could actually label it if I want. So if I do horizontal axis, I could find, well, actually, it's not a big deal. But just know that the x-axis is going to be time for us right now, and y-axis is going to be our moles, which is going to be kind of like our concentration as the way this is supposed to go. And it plotted the graph, and I already have it set that it gives you your trend line, and it says the R-squared value is 0.971, which is pretty good. And if you remember, a plot of, and this is why I got to just make sure I can get this labeled, I could definitely customize where I label the graphs. Chart, there we go, chart and axis titles. So title is going to be this, and then I could do chart title, and then I'll do horizontal axis. And I'm going to say my horizontal axis is time in seconds, and then I'll change vertical axis to amount of moles produced. Okay. All right, and so now I have it labeled, okay? What I want you to gain practice in doing is plotting those 3 different types of graph. So I could do moles versus time. I could do natural log of moles versus time. And I could do 1 over moles versus time. This is kind of like in the integrated rate law, they use concentration. So it would be concentration of A versus time. It would be natural log of the concentration of A versus time. And it would be 1 over the concentration of A versus time. All right, and so we're going to use, for our purposes in lab, for our lab, we are going to treat moles as molarity, okay? I'm not saying that moles is equal to molarity. We're just going to treat it as moles is molarity. And so if it is linear with moles versus time, it's 0th order. And that you have to look at the R, and for all of these, you're looking at the R squared value, right? If it's linear or more linear with respect to natural log of moles versus time, it's first order. If it's linear with respect to 1 over moles versus time, it's going to be second order. And we're going to gain practice on this coming up, but let's make sure that we're able to plot our data of time versus, maybe let's do natural log of moles, natural log of the moles of H2. And then we'll also do 1 over the moles of H2. Now, I'm going to leave the first two spots as 0 because I have 0, 0, 0. It's going to be a mess. The way that you could plot doing natural log or get your values of natural log is by hitting the equal sign, right? And then clicking on whatever cell you wanted to do a calculation towards. But before I do that, I want to do natural log. So if I put ln and then left parentheses and click and see what it says returns the logarithm of a number based on this. And then in the parentheses is whatever value I want it to do it to. So I'm clicking on this cell, which is D3. It has a number in there. And you can already see it's doing the calculation. I'm going to put right parentheses and boom, it did the calculation for me. And now if I wanted to do the calculation to all of these values, all I have to do is click on where I did the calculation in the cell, find the box in the corner, and drag it down. And now it has beautifully done all of the calculations for me. I'm going to do the same thing for 1 over moles of H2. The way that I could do this is do equal sign. I want it to be 1. And then I do like the slash. Slash means divided. And then I'm going to do left parentheses and click on whatever values I want. Left parentheses, click on the value that I want to do 1 over. Right parentheses, and it did the math for me. And like I said before, I find that square box in the corner and drag it down, and it did all of the calculations for me. All right, and now if I want to plot this data, what I want to do is I want to click and drag on my time. So clicking and dragging on the time, I'm already setting my X values. I'm going to click on Control on the Chromebook, and I'm going to scroll over to the other column that I want to record, which is natural log, and drag all the way down. If you don't do that, you're going to get all of this data in there, and that's going to be all sorts of messed up. So what you do is you click and drag on the X or the left column, and then hit Control and drag on whatever other column you want to plot. And then I'm going to do Insert, Chart, and you don't want column chart, you want scatter plot. Okay, and so I'm doing a scatter plot, and I want to go to customize, and I want to make sure I could see my trend line, and then I want to make sure I could see the equation with the R squared value. Okay, so it has plotted my data. Actually, I might even be able to delete the 0 point. All right, the 0 point always messes it up. All right, I've plotted this data. Okay, don't have the 0 in there. We can even just ignore the 0 part for all of this whole column. All right, I've gotten rid of the 0 point. I've plotted this data, and I did, for this fake data that I made up, I did the natural log of moles of H2 versus time, and look at my R squared value now. Oops. Look at my R squared value now versus my R squared value for just time versus the amount of H2, or moles on the y-axis. So look at this. Moles versus time, I get 0.955. Natural log of moles versus time, I get 0.99. So what I would like you to be able to do is, if I look at my graphs, whichever one is more linear, that's the graph that shows the order. So remember, we said if I have the natural log versus time, if I have the natural log versus time right over here, like I mentioned, and it's more linear, it's going to be first order. Okay, now what I also want you to do, and I'm not going to show that in here, is also plot the time versus 1 over the moles of H2 and see if that R squared value matches up. Don't plot the zeros. See if that R squared value matches up, and see if the R squared value is even higher, having to be 1. If the R squared value is 1, that must mean that the reaction is second order because it is more linear. So this is what I want you to do right now for the weekend. And then eventually we'll talk about how we read reaction orders with respect to reactants. This is just a sample exercise and being able to plot and interpret graphs.